Now we will talk about third law of motion. Alright, we have learned about the first law which tells us the behavior of any object, and second law tells us that how much effort is required to change the state of an object. Alright, now the third law tells us what happens to something which is exerting force on the other object. Alright, so like I think most of us know it, like a statement, every action has equal and opposite reaction. So this is how most of us know this Newton's third law. Now the action and reaction, they are the forces. All right, so every force has equal and opposite force. That is what it means actually. Now this equal and opposite force is not applied on the same object. Like for example, if there is an object A which applies Fa on B, okay, then B will apply Fb on A, and Fb and Fa are equal and they are opposite in direction. Okay, so if I apply force on this board, all right, F force, suppose I apply 5 Newton force on the board will apply 5 Newton force on me also. Okay. Now, this may sound weird, but then we are using it in our day-to-day life. For example, when you are walking on the surface, which direction you are pushing the floor? You're trying to push the floor backwards, right? And you are moving forward. Why you are moving forward? What makes you accelerate? Which force on you makes you accelerate forward? It is a friction, right? The friction from the surface. So you apply force on the surface backward, right, which is friction only, and equal and opposite friction is applied on you, which is forward. Okay. Now take another case. For example, if you are swimming, if you have to move forward, which direction you push the water? You push the water backwards, right? When you push the water backwards, the water will generate equal and opposite force on you, which will be forward. And that is why you move forward. Okay. Another example. Suppose I am standing on the ground and I want to jump. Which direction I will push the ground? I'll push the ground downwards, so that same amount of push I experience in equal and opposite direction. Okay, so that's the reason why I may be able to jump, because when I push the floor downwards, floor pushes me upwards. Okay, so we see that Newton's third law is applicable in almost every scenario. In fact, you should be able to see forces in pairs. What I mean is that if there is a force, okay, suppose there is a force F exists somewhere, okay, now this force must be applied by something, right? This force is applied by something. So there is one agent, there is an agent of force and one object. The agent of force applies force F on object, so object will apply force on the agent also according to Newton's third law, equal and opposite. That is what its pair is. Okay, now I think we need to discuss this little bit more. So let us take up more example to understand what is happening here. Okay, suppose this is Earth. Okay, there is an object in air. Alright, now this object is pulled down by Earth with a force of mg. Right, now where is a pair of this force? Who is applying mg? The earth is applying force on mass m downwards. Okay, so this mass will apply force on earth mg. This is the pair of this mg, equal and opposite. Right? Let us take few more examples. This block of mass m kept on a surface. Right? Now, what are forces are there? There is mg force. Then, since there is a contact, there will be a normal force, and normal always pushes along the common normal to the surface. So, this will be normal force on mass m. Okay. Suppose this mass m, there is external force F acting on it, and because of that, it accelerates forward. Okay. And suppose this is a rough surface, it's not a smooth. So, will it experience friction? It will experience friction in backward direction. Let us call it Fr force. Right? Now I need to find out pairs of all the forces. Okay. I know pair of mg is what? On earth, mg. Pair of this F is what? Someone is applying force F. Suppose there is this person who is applying force F on this block. So this person will also feel the force F. That is what the pair is, right? But then since earth and this person is not involved in the diagram, I don't need to draw pairs for that. Okay, because I will not be writing equations for them. But if I have to write down equation for the floor, then I have to draw the pairs of forces on the floor. Now see what is happening here. The friction is applied by the floor on mass. Fine. So equal and opposite friction will be applied by mass on the floor. So which direction it will be? It will be like this. So this is the pair of friction. Any other force the floor applies on the block? Normal reaction, right? Normal reaction out like this, it applies the floor on mass m. So m applies normal reaction on the floor in opposite direction. So this is the pair of normal reaction, right? See that normal reaction here also tries to push the floor. Okay. So these are the pairs of the forces. Many times I have seen students, they miss the pairs, right? So a very simple rule just keep in your head, always ask yourself, whenever you draw some force, do you know where its pair is? If you are not sure where the pair is, probably you are doing it wrong. Okay. Let us take few more examples. Suppose there is one inclined plane like this. This is mg because of gravitation. This is normal force. This is friction. I'm talking about on the block. What are the forces? Okay. Let me draw a pulley also. There is a tension. So these are the four forces acting on the block. Let me try to find out where are the pairs of these four forces. Okay. The pair of mg is what? Again on earth, because earth is applying mg force. So I don't need to draw that. What else? I just remove the block to draw the pairs properly. I keep the pulley like this. Okay. Now pair of tension. This tension is applied by this part of the string like that. So equal and opposite force is tension T in this direction. Okay. This normal force is applied by this inclined plane on the block in outward direction. So the inclined plane will feel normal direction like this. Equal and opposite, right? Now friction. Friction is in that direction on the block. So on the wedge, friction will be equal and opposite. Okay, so like that, you can easily identify the pair of the forces. Fine. One thing we have observed here is that this tension, it is immediately changing that direction. If I cut the string like this, one end the force is like this, and the other point the force is in opposite direction. Okay, so these are the internal forces. Internal forces will always be equal and opposite. Okay? Fine. So this is what the Newton's third law is all about. Now, in the next topic, we will be taking up a very important concept called free body diagram. And once we are done with free body diagram, we are equipped with all kinds of tools we need to solve any numericals from this chapter.